All right, everyone, this is Mr. Blay again. This is the sort of last video here in the series. This is about prediction intervals. So what we're going to do here is we're going to work with our equation and our information to try and make a prediction on sort of monthly costs for these machines. Again, the data for this was based on the previous video. Okay, so what we're going to do here is the first thing we're going to do is kind of look at the question. It says for data in this example, find a 95% prediction interval for the monthly maintenance cost of a machine that is 3 years old. So before we can do a prediction interval, let's just make a prediction. Okay, so predictions are always made using your line of regression. Okay, now this line of regression was calculated in the previous video. So if you haven't watched the previous video, that is where I'm getting this information from. So this is the regression line here for our equation. So let's just make a prediction of monthly maintenance cost for a 3-year-old machine. If we make that prediction, we're gonna have 55.565 plus 8.13 times 3. All right, if we calculate this, we'll have 55.565 plus 8.13 times 3. All right, so that is going to give us a prediction of approximately 79.955. So in other words, for 3-year-old machines, it'd be about 80 bucks, give or take. Okay, but that give or take, we're actually going to figure out specifically what is the give or take. What is actually the range of prediction? So that if you really have a 3-year-old machine, you can truly figure out where it's going to fall. Because you know what? It may not be $80. Okay, it might be a little above, might be a little below. But how big above? How big below? That's what this formula helps us do. Now again, I know that this formula looks a little bit daunting, but honestly, it's really not that bad. Okay, if you look, you'll notice this value right here is the prediction value we just wrote down. Okay, so we already have that prediction value. This value, the standard error of estimate, we already did that in the previous video. Okay, so again, if you haven't done the previous video, make sure you go do that first. So this is already done. This is already done. Okay, the n values, you'll notice there's 3 of them, here, here, and here. Those are also already done. Okay, in the data set, we already figured out that there are 6 data values, so we already know n. So the only things we have to really figure out here, okay, are some of these x values here. So you'll notice there is a small x value. Okay, now again, the small x value is actually 3 in this case. Because again, see the small x value right here? This small x value and this one match up. So since we plugged in 3 here, we're gonna have to plug in 3 to this formula. Okay, there's also the mean, okay? X with a line over it, okay? There is the summation of x squared, which we're gonna go find here, okay? And then there's also the summation of x, which has a squared value on it. Okay, so summation of x. Notice that these 2 things here are not the same. Not the same, okay? So again, in your calculator, you're gonna go to the exact same place you did last time. Okay, if you watched the last video, this was stat, calculate, 2 variable stats. Okay, and if you go down to calculate, you're gonna find all the things you need. You're gonna find your mean right here at the top, which is 3.33. Okay, you're gonna find your summation of x, which is 20. You're going to find your summation of x squared, which is 82. These are really all the numbers you're going to need, but now you need to plug them into this formula. The only thing you'll notice is missing is this t value, which we are going to look up in the t chart. One thing to keep in mind though, n-2 as your degrees of freedom. Okay, and so the reason for that is if you watch the last video, in the standard error of estimate, you use n-2 in the formula. So when you do the t value, you also use n-2. So which means our degree of freedom for this problem is 4. So if you go to your T chart, okay, notice again it's 95%. So here's our T chart, okay? You go to 4, you go down to 95%, and that's your number, 2.776. Apologize if that's hard to see, but you should see it on your own T chart. So the T value is 2.766. Oh, sorry, 776. I wrote that down wrong. Okay? And so now you got all your numbers. So the main important thing is that you plug them all into the correct locations. Okay? So again, y prime or your starting value, that is 79.955. You have plus or minus. T-score, 2.776. Standard error of estimate from the previous video was 6.5. Okay. And then you have your entire square root here. All right. So I'm going to slide my calculator up for a minute just because I think I'm going to need the room. So I'm going to have the square root. And in here, I'm going to have 1 plus 1/6 because n is 6 plus, and then I'm going to have a large fraction. So n is 6. I'll have my x value is 3. My mean is 3.33. Put a squared on the outside, okay? Because again, the squared is on the outside. Okay. Down at the bottom, I'm still going to have my 6. That's going to be multiplied by the summation of x squared, which is 82. And then you're also going to have the summation of x, which is then squared. The summation of x is 20, and you put a squared on the outside of that. Okay, so turns out I did actually have enough room, so there's the calculator again. Okay, so at this point, this is your entire formula with all the numbers that you need and all plugged in. So now the trick is to make sure you calculate everything correctly in your calculator. So one of the things I would always suggest when you do this, okay, is you always start on the inside of the square root. So you're always going to start in this messy area. You're going to essentially start with that first. Okay. So this here, you'll do 3 minus 3.33333. And again, since you know that's a repeating decimal, sorry, you can't see that. Okay. Since you know that's a repeating decimal, just type in a bunch of them. Okay, to make it as accurate as possible, and then square that answer, and then multiply it by 6. Okay, so this numerator here in the formula is 0.666666. Okay, now the denominator. Okay, again, you'll still have the plus 1/6, you'll have the plus 1, and it's still all in a square root. The denominator here, you can do 6 times 82, and then subtract. Make sure you put this part in parentheses. Subtract 20 squared from it. Okay, so you now get 92 as a denominator. What you're essentially going to do is take this fraction, add the 1/6, and add the 1. So then you'll have the figure that goes in the square root. I'll kind of scroll this up a little bit here. All right, so here you've got the 0.6 repeating divided by 92. You're going to add 1/6. Make sure you put the fraction in parentheses and you add the 1. So your number inside the square root is the number 1.1739. Okay. Now, again, bring everything else down. You've still got the 6.5. You've still got the 2.776. And you've still got the plus or minus your original value. Okay. Square root this and multiply them together. And then you will basically just do the addition and subtraction to get your final interview. All right, so if we square root our previous value, okay, which was that one, okay, we're going to square root it, and then we're going to multiply it by 6.5, and we will multiply it by 2.776 to give us the number 19.55. This is the number you will be adding and subtracting from 79.55. Okay, so your final interval, is if you take the 79.955 and you add that answer, add that answer, there we go. You're going to get a high prediction of $99.5, because again, we're looking at repair costs, and you're going to get a low value, and 19.55, you're going to get a low value of $60.40. This is your interval, okay, for a 3-year-old machine. So again, we talked about at the beginning, okay, that our line predicted $80, okay, give or take. But the reality is, if you've got a 3-year-old machine, more than likely, okay, and 95% likelihood, your actual costs are going to be between basically $60 and just about $100. Okay, so there is quite a range there, depending on your 3-year-old machine, depending on how well you take care of it. All right, that is your final prediction interval for a 3-year-old machine.